So today we will continue 6.4 يا شباب. As you remember in the previous class we have seen how to sketch the graphs of secant and cosecant. Today inshallah we will see how to sketch the graph of tangent and cotangent. Let's go over what we have done quickly. If you remember يا شباب how to sketch the graph of sine of secant and cosecant, you will use the graphs of sine and cosine as a guideline. So to sketch the graph of secant, you will use the graph of cosine as a guide. At each top you will draw a cup, at each bottom you will draw a cup. The domain of secant, because you know that secant it is 1 over cosine x, the domain is all the real numbers except the zeros of cosine. And the range is from negative infinity to negative 1 and from 1 to infinity. Now, what is special about this function that it has vertical asymptotes? It has vertical asymptotes. What are the vertical asymptotes? They are the numbers that you exclude from the domain. So they are the zeros of cosine. Wherever cosine is 0, these will be vertical asymptotes for secant. The same, I think, ya shabab, for cosecant, but here you will use the graph of sine as a guide. And this is what you have. Notice that the vertical asymptotes here are the zeros of sine, because cosecant it is 1 over sine. So it is, of course, in by the zeros of sine. The same range. Of course, and also it is odd. What else we need to know, ya shabab, and it is indeed the most important part, is how to find the vertical asymptotes in general. So if you have all the informations, all the transformations, all the kinds of shifting and reflecting and stretching or whatever, how to find the period is 2 pi over k. K is the coefficient of x. If you want to find the horizontal shaft, put what is here inside to 0 and solve it for x. The vertical shaft is c. The vertical asymptote. Now, how to find the vertical asymptote for secant, for cosecant? For secant, you will put what is inside. You will put what is inside equals to the zeros of what? These are the zeros of cosine. I prefer to write it this way. They are the same, but this one is much easier for you. So use this instead of 2n plus 1 over pi. And these, of course, are the zeros of sine. This is also important, shabab, how to find the range. How to find the range of secant and cosecant. The range will be from negative, it was طبعا يا شباب before any shifting, it was from negative infinity to negative 1 and from 1 to infinity. But when we have these shifting and stretching, you need just to consider this is A and this is C. I think now we are ready to go to see the graph of tangent. Now, what we will do, inshallah, today, we will sketch the graphs of tangent and cotangent. If you remember, Shabab, what was the period of sine? Sine, cosine, secant, cosecant. What was the period, Shabab?
2 pi.
2 pi over k.
If you have x for any of these functions and you add 2 pi, you will get the same function, but without, of course, this will be sine x, and you can compare the remaining by the same way. By the way, this is still the same for tan, by the way, Shabab. Tan x plus 2 pi, it is still tan x. It is also periodic, the same for cotan. But what is special about tangent, Shabab? What is special about tangent is there is a smaller number. There is a number smaller than 2 pi that satisfies this. What is it?
Pi.
It is pi. Tan x plus pi equals to tan. And yeah, Shabab, I think you know why. I told you that before. If your angle, let's say, if your angle is here, and you add pi, it will be where? It will be here in the third. And you know that in the first and in the third, tan and cotan, they are the same. They have the same value and the same sign. Positive, both are positive. So, and we defined the period. If you have any function, if you have a function that if you add a number and you get the same function, The smallest positive number that satisfies this is called the period. So the smallest number in the case of tangent and cotangent, it is pi, not 2 pi. So because of that, these two functions two functions have a period pi. So this is the first difference, and this will be so nice, Shabab, by the way. You will see how easy to sketch the graph of these functions because their period is only pi, as we will see. Now, do you know how the graph of tangent looks like? If you don't, what you will do? You will make a table of values. And this is, you will not do that, I'm sure. You don't need it. Just let's assume that for those who started sketching the graph of tangent at the beginning, what they did like this. Notice that it is not defined at pi over 2 and negative pi over 2, because you know that it is cosine, that tan x is equals to cosine x over, no, tan x is what, Shabab?
Sine over cosine.
Tangent x, thank you, you're right. Let me just put there sine x over cosine x. So look, it is undefined at pi over 2 and negative pi over 2 because at these values cosine will be 0. So what we have vertical asymptotes at these. So if you plot these points, you will get a graph like this. And these are the vertical asymptotes. Now, ya Shabab, if you look at the graph, it looks like this. This is 0. This is negative pi over 2. This is negative pi over 2. And the graph will be like this. Here we are. This should remind you, ya Shabab, about the graph of another function. What is it?
X to the power of 3.
X to the power 3, x cubed. You are right. Yes, it is similar, ya Shabab. So you can make a connection between them just to memorize. So this is the graph, of course. It will go, ya Shabab, to infinity up and the negative infinity down. And this shows you that the range is all the real numbers. Okay. Now, of course, this is one interval, ya Shabab. This is one period. Look, from here to here, what is the length of this interval? It is pi, because the period is pi. What is good about tangent and cotangent, ya Shabab? Here you have vertical asymptote, here you have vertical asymptote. The length of this, or the distance between them, it should be equals to the period. So the distance from here to here, it is equals to the period. Not only that, at the middle here, the midpoint, it is x-intercept. This is also so nice for you to sketch such graphs. So the period,
دكتور
yes.
الساين والكوساين كم كان البيريد؟
2 pi. It was 2
2
pi.
باي الدبل. اي اوكي بس بتذكر.
You cannot have this for sine and the other functions. You cannot have the same value with the same sign unless you make a full rotation. But here, half rotation for tangent and cotangent give you the same value and the same sign. If you want to think about it like that, but it is more general. We are talking about x here. X is any real number, not necessarily an angle, specific angle that you have an idea about. So, yeah, Shabab, this is one period. So this is one part from the graph. Now, if you want to draw more parts of this, what you will do? You will go to the first two vertical asymptotes. You will add the period. You will add pi. So what is plus pi? It will be 3 pi over 2. So this is the next vertical asymptote. Here, subtract pi. You will have negative 3 pi over 2. This is the one to the left. Now, the same for the x-intercept. Here at the middle here, you have x-intercept. You can find it as a midpoint, or you can add at the period. So this is what is nice. So easy to sketch the graph of tangent and cotangent. They are also, Shabab, even odd. You know that tangent is odd, clearly, because it is symmetric about the origin. This is much better, I think, Shabab, and clearer. And what you need to know about this function, that it has vertical asymptote at these values. Again, I prefer to write this as pi over 2 plus n pi. The x-intercepts, Shabab, are n pi's. So of course, they are the middle points. The period is pi, it is odd, no amplitude because there's no minimum or maximum. It goes up and down. Now, how to sketch the graph of 2 tan x? It is the same as the graph of tangent, but reflected or shifted or what? Or stretched or shrunk. It is the same as the graph of tangent, but it is what? Vertically stretched by 2. Let's see how the graph, this will not affect the graphs too much, ya shabab. The shape, I'm talking about the shape. The shape will be almost the same. Look, the blue one is tangent. Now the red is 2, the double of tan. What happens at pi over 4, for an instant, at pi over 4, it was 1. Now at pi over 4, it becomes 2. Just like that. This is the only difference. So it is a kind of stretching. For us, they look the same. If you ask me to sketch the graph of 2, I will make it also like this. So it is the same. If you allow me just, Shabab, for a minute, and I want you to think about this, about negative tan x. Think about this, please. As the graph of tan, but what?
Reflected.
Reflected in the?
In the y-axis.
No.
X-axis.
By the
Because
way,
it's
it is the same, by the way. Why they will be the same? Because tan negative x is negative tan x. They are equal to each other. Because it is odd, yes. Look, the blue one is the graph of tangent. If you reflected in the x-axis or the y-axis, the graph you will get the red one. Okay, so interesting. This is not only for tangent, for all the odd functions. Now for cotangent, the domain will be all the real numbers except the vertical asymptotes, which they are cotan. It is cosine of x over sine of x. So here, these are the zeros of sine. The range is all the real numbers, and of course, this is how it looks like. This is the first, yes. This is the first part, ya shabab, of the graph of cotan. Of course, you can do that by plotting points. And here we are. Look, it looks different from. You need to distinguish between it and between the graph of tangent. This is the graph of tangent. It was like this. This is pi over 2. This is negative pi over 2. Okay. Mute yourself, ya shabab. If you don't have a question, if you don't want to answer or ask, no need to keep your mic open. Now, this is the graph of tangent. This is the graph of cotangent. Cotangent, the first 2 vertical asymptotes are 0 and pi. The midpoint here, the x-intercept, it is pi over 2. So what was in the case of tangent? What is in the case of tangent is vertical asymptote. Here it will be x-intercept and vice versa. Remember the first part, then add the period, you will get the other parts. These are, shabab, the vertical asymptotes. The most important part is this. Of course, you know that it is also odd. So this is tangent. This is negative tangent. This is cotangent. This is negative cotangent.
Doctor, if we manipulate with it, can it be the same, that graph?
Which one?
The cotan, we can make it the same as tan, right?
By using
shifting transformations.
By using the co-function. You not only that, ya Faisal, you can do that with sine and cosine, with tan and cotan, with secant and cosecant, because of the co-function identity. You know that tan x is the same as cotan, as the same as cotan. What? Pi over 2.
Pi over 2 minus 6.
So if you make a reflection, then you shift and you make it like negative x minus pi over 2, and you get the negative out. They will be the same. The graph of tangent is the same as the graph of this graph. Of course, not only, this is not only for tangent and cotangent. You can do that also for sine and cosine. You can do it also for secant and cosecant. Thank you for reminding me about this point here, Faisal. Okay, now, but they are different, ya shabab, by the vertical asymptotes. Be careful. Some of you, they say, oh, cotan, it looks like negative tan. Look, they looks like each other in the shape, but indeed they are totally different. Look at the vertical asymptotes here and here. They are not the same, of course. And of course, the x-intercepts are different because this is cosine over sine, this is sine over cosine. Now the period, ya shabab, again, when we have tan x or cotan x only, the period is pi. Okay, but when you have tan kx, whatever here, even if you have a plus c, whatever, or even here x minus b in general, the period will be pi over k. Pi over k. Remember that. Now, what is the first interval? If you want to sketch the graph, what is the first interval that you will sketch the graph on? Or what is the first two vertical asymptotes? Ya shabab, if you remember for tangent, it was what? It was between negative pi over 2 and pi over 2. Do you remember? So now, what we will do, we will just use kx, this is kx, between pi over 2 and negative pi over 2. The same. Divide by k, it will be pi over 2k, negative pi over 2k. So this is the interval that you will sketch your graph in. Or you can say these are the first two vertical asymptotes. For cotan, shabab, for cotan, do you remember the graph of cotan? It is the first two vertical asymptotes are 0 and pi, and the graph of cotan, it looks like this. Oh, what is that? It is very bad sketching. Here it is, something like that. Now, the same here. What we will do, we will put kx between pi and 0. So x will be less than pi over k and less than 0. These are the first two vertical asymptotes. Let's see, let's apply this with this. This example, part A. How to sketch the graph of y equals to tan 2x. This is a horizontal shrinking, by the way. Now, let me ask some specific students. Sultan al-Mandil, are you here, Sultan? Are you with us, ya Sultan? Sultan al-Mandil.
Yes, doctor.
What is the period of this function, ya Sultan? Tan 2x, what is the period?
I think that it is pi over 2.
You are right. It is pi. Look here. It is pi over k. This is k. So the period is pi over k. You are right. Thank you, ya Sultan.
You're welcome.
Now, ya shabab, what is the interval that we will sketch the graph on? So this function, we need to find the first two vertical asymptotes. How to do that? As I show you, this is what you need. What we will do, the interval that we will sketch them, and these are the first vertical asymptotes, ya shabab. These are two vertical asymptotes. Now, how to find these? How to find them? Just put the argument, which is 2x, put it between negative pi over 2 and pi over 2. Why negative pi over 2 and pi over 2? Because we are talking about tangent. Our function here is tangent. If it was cotangent, we will put it between 0 and pi. Solve this for x, you will divide both sides by 2. Here we are. So these are the first two vertical asymptotes. So what you will do, you will just go to this is negative pi over 4. This is pi over 4. You will sketch the graph of what? Of tan. The middle point between them, which is 0, and there is no reflection. This is the graph of tan. And this is the graph. Here it is. This is the part that I talked about, the red one. Now, you can, of course, go to the right, add. Now, the length of this interval, ya shabab, must be equals to pi over 2, which is the period. Look, it is pi over 4, and pi over 4 is pi over 2. Now, add pi over 2, you will get the next vertical asymptote. Add pi over 2, you will get the next one, and so on. You will do subtract also. Notice also that what is the midpoint, the x-intercept? The x-intercepts are the midpoints between the two vertical asymptotes if there is no vertical shift. If there is a vertical shift, this is another issue. Okay, now let's go to example number 2, or part 2. By the way, you have to notice that there is a connection between this graph and this graph. So let me ask you this question. How to obtain the graph of this function from the graph of this one? How to obtain this graph from this graph?
We just move it to the right with pi over 4.
Ryan, by
Yes.
shifting?
Pi over 4 to the right.
By shifting, يعني this graph, which is this one, we will just shift it to the right as Ryan said. You are right, Ryan. So this is by shifting to the right. You are right. So what we will do, Shabab, this graph is the same as the graph in part A, but shifted to the right by over 4. So what we will do, if we have this graph, let me show you. If we have this graph, just what we will do, we will just, what is at 0 will be at pi over 4. So the vertical asymptote that is at pi over 4, it will be at pi over 2. So you will go here and do this. So the vertical asymptote will be here. This will be vertical asymptote. This will be the second vertical asymptote. And now the graph will be like this. This x-intercept now it is pi over 4. And this is pi over 2. And so on. You can repeat that. But look, let me show you the graph. And I will mention that later. Look at the graph. This one is obtained from this one by shifting to the right, pi over 4. Look, what was at 0, it becomes at pi over 4. What was at pi over 4, it is pi over 2. But what about if I don't? What about if I don't have this? How to sketch this from the scratch, from the beginning? What you need to do in that case, you need to find the first two vertical asymptotes. عشان ترسم الجراف between them. So how to find them? You have two methods, by the way. One method is to put the argument, what is here, put it equals to negative pi over 2 and pi over 2 and solve them. This will give you the first two vertical asymptotes. But as I told you before, I prefer to combine these two equations in a single inequality. What is it? This one. Put the argument between negative pi over 2 and pi over 2, divide by 2, add pi over 4 by 4 side, you solve it. So now these two are the first vertical asymptotes, and you know from where to start your first part of the graph. So the first part is from 0 to pi over 4. These are two vertical asymptotes. The distance between them, check. It should be equals to the period. What is the period? Pi over 2. Is it pi over 2? Yes. So you are right. Excellent. Now, these are guidelines for you how to sketch the graph. I think you just need to think about what is the best interval that you need to start with. I will let you, Shabab, start with sketching this. Please try to sketch. Okay, Shabab. Now, how to sketch the graph of this function? To sketch the graph of this function, what you need to do? Anyone? We need to find the first two vertical asymptotes, and then we will sketch the graph of cotangent like this. Okay? So the question is, what are these two? How to find them?
The period. You need to find the period.
The period, clearly the period is pi over 3. So this is good. So the distance between this and this will be pi over 3. What we will do, Shabab, we will put the argument. There are two methods, I told you. But because this is of course, let me before doing anything. The best way is to put the argument, what is inside cotangent, between what and what? Do you remember what we said? What the graph originally, what is the graph of cotangent? It is from 0 to pi, the original graph for cotangent x, when we have only cotangent x. So now it will be between 0 and pi. You will solve it for what? You will solve it for x greater than pi over 4. Then you will divide by x. So it will be 4, 5 pi over 4. You will divide by 3. It will be 12. And this will be pi over 12. Now these are the first two vertical asymptotes. You will sketch the graph of the first part of cotan between these two vertical asymptotes. Okay, it is of course better to write it in the standard form, Shabab, if you want. The standard form here is what? To take 3 as a common factor, and this will tell you that this graph will be the same as the graph of 3 cotan 3x, but shifted pi over 12 to the right. But if you don't plan to sketch the graph of this one, no need. Now, again, if you know what are the vertical asymptotes, so this is one way. Another way to both this equals to 0, both this equals to pi, or just solve this. Yes, Shabab, anyone? Why? Mute your mic, Rayyan, please. If you don't want to ask or answer, don't open your mic. Again, this is the method that I show you. Now the graph that you will sketch the graph between these two vertical asymptotes. Now these are the two vertical asymptotes. This is pi over 12 and this is 5 pi over 12. Now this is the first part. How to continue doing the next part? Add the period. What is the period of this function? As we did, it is pi over 3. Add pi over 3, you will get the next one. Add pi over 3, you will get the next one. Subtract pi over 3, you will get the next one to the left, and so on. At the middle, always at the middle, there is an x-intercept. There is no vertical shift. So there is an x-intercept in between. And of course, add the period, you will get the next x-intercept, and so on. I wish that this is clear, Shabab. Let's summarize. Yes, I add here some exercises for you, Shabab. Yes. Who wants to ask?
خلاص.
I brought here some additional exercises for you, Shabab, with full solution. And this is the summary of tangent and cotangent graphs. The most important part, Shabab, is this part. For the others, I think you know that what is the period. And this is, of course, how to find the vertical asymptote for tangent. Both the argument equals to pi over 2 plus n pi. Here, both it equals to n pi. Now, I think this is a guideline for you how to sketch the graph. I think you don't need it at all. Now, let's practice by solving some old exam questions. What is the number? So he is asking about here about how many. What is the number of vertical asymptotes of the graph of this function? If he stop here, what will be the answer? What is the number of the vertical asymptotes of this function, Shabab? Forget about this. Of course, infinitely many, because you know that the graph of tangent, it will go like this forever, the vertical asymptotes. So it has infinitely many. But he should give you an interval. Otherwise, the answer will be the infinitely many, of course. So he wants just the vertical asymptotes inside this interval. Yalla, Shabab, take your pen and paper, please, and start to practice, please. Let me launch polling for you to choose the right answer. Try to think about what are or how many vertical asymptotes for this function in this interval. Be careful. It is open at negative pi, closed at pi. And of course, what is the function, ya Shabab, that if we put here, the question will be the same? The answer will be the same. Do you know? The vertical asymptotes of the vertical asymptotes of tangent are the same as the vertical asymptotes of which function?
Cotan.
Really?
Maybe.
X to the power 3.
Are you kidding? What we are doing since the morning? We are talking about tan and cotan. They have the same vertical asymptotes. Allah musta'an, Allah musta'an.
No,
Yeah,
they don't.
tangent, it is sine over cosine. Cotangent, it is cosine over sine. How they can have the same vertical asymptotes? Are you kidding? Tangent has the same as the vertical asymptote as what? As secant, because they have the same denominator, ya shabab. Because what are the vertical asymptotes? They are the values at which the denominator is 0. Now for cotan, they have the same one with cotan. So if I put here instead of tan, secant, the question will be the same, the answer will be the same, the solution will be the same when we ask about the vertical asymptotes. Similarly, the vertical asymptotes of cotan are the same as the vertical asymptotes of cosecant. Come on, guys, please. Is that clear? And you know now why?
Clearly.
Yalla, shabab. Let's see what is the progress. Good. So far, 4 students, mashallah, how they did this quick, mashallah. Let's assume that they solved. I will assume that they solved completely. And it is not difficult, by the way. But you have to be careful. You have to make sure that you didn't miss any vertical asymptote in that interval. So, four students out of 18 so far. Let me give you a hint, ya shabab. There are many methods, ya shabab, to solve this question. And you can choose any one you want. I will show you these 3 methods here for this question. But for the next one, I will use one method only. One way is to do what? One way is to put this as we did before, as I show you how to sketch the graph, and you will try to sketch the graph. So the first method, you can think about it like what? Sketch the graph, but no need to do, ya shabab, the reflection, no need to do the vertical shift, forget about that, no need, because we are talking about the vertical asymptotes, which will be the same. Now, what you will do, you will put it between what and what? This is tangent, so we will put it between what and what, ya shabab? Between negative pi over 2 and pi over 2. Then we will solve it for what? For x. So this will be 2x. And here we will have 0. Here we will have negative pi. Divide by 2. You will have here 0. You will have negative pi over 2. Now these are the first vertical asymptotes. And we are lucky because they are here. Look, both of them are here. But are they the only vertical asymptotes in this interval? We don't know. How to check? So some of you, they said, oh, 2. No, this is not the way. This is the method that always we use to find the first 2 vertical asymptotes. So what you should do in this case, you should go to the x-axis, put here negative pi over 2, put here 0, and ask yourself, what is the period of this function? The period of this function is what? Pi over 2. So what you will do, you will add pi over 2, add to 0 pi over 2. This is the next one. So this is the first one. This is the second one. This is the third one. Add more. Add pi over 2. It will be 3 pi over 2, and so on. So if you add, it will be pi, not 3 pi over 2. If you add more, it will be 3 pi over 2. Is that right? Go to the left. Subtract pi over 2. What you will have here? Negative pi. Subtract. You will have negative 3 pi over 2. Now ask yourself, which one of them is in? Which one of them is out? Yalla shabab. In or out? Is this one in or out? 0 is in. Pi over 2 is in because it is between negative pi over 4. What about pi itself? Yes, it is. So this is the closed of my interval. This one is not in. So this is not in at all. This is out. Now negative pi is in. Negative pi over 2 is in. Negative pi is out because the graph is open. So this is not included. Of course, this is not included because halas, the interval is stopped here. It is open here. So this is the end of the interval. So how many shabab we have? This, of course, we said it is not in. 1, 2, 3, 4. So the answer is A. Okay? Let me end the polling and share with you the results so far. So good. Also, six students choose A, 2 with B, 2 with C, 4 with D. Okay. Now, what is not good about this method, ya shabab, that you may miss some vertical asymptotes. You may forget them. So be careful about this. So there is another way. This way, ya shabab, is the original way that we use when we sketch the graph, when we want to sketch the graph. You can do this algebraically without even finding the period. You don't know to find the period. You don't know to sketch the. You don't need to sketch the graph, but you need to solve it algebraically. How to do that? You will put the argument between what and what? Between negative pi over 4. Sorry, between negative. We did that. That was the first method. I forget. We did in the first method. We put it, or I erase it. We put it between negative pi over 2 and pi over 2. This is the first method. The second method is what? To put the argument equals to, this is the argument, equals to the zeros of what? This is tangent. It is sine over cosine. So it is equal to the zeros of cosine. Now solve this for x. This will be cancelled with this. This cancelled with this, and you have now 2x divided by 2. It will be x equals to n pi. Now these are all the vertical asymptotes. We don't need all of them. We need just the ones that are between greater than, strictly greater than negative pi and less than or equals pi. So what we will do, one way is to start trying n equals to 0. If n equals to 0, what you will have? 0. It is n. But n equals to 1, it will be pi over 2. It is n. 2. You will stop here at n equals to 2. Notice here at n equals to 2, what do we obtain? We obtain pi, which is the end of the interval. Khalas. Don't try n equals 3. Don't try it, because for sure it will be greater than pi. It will be out of the interval. Now you need to try some negative values. So you will try some negative values, like n equals negative 1. It is n. Try negative 2. When you try negative 2, what you obtain negative pi. Negative pi, it is at the end of the interval, and it is not n because it is open. So this is not included. So this, we have 1, 2, 3, 4. We have 4 vertical asymptotes. There is a better way, in my opinion, there is a better way how to find this. Instead of trying these values, you need to know how many n's I need. So method number 2, you do the same up to here. Now this, put x between negative pi and pi. What is x? X is n pi. Now I need to know what are the n values that I need. So I will solve this for n. So multiply both sides by 2. Divide by pi. Say by pi for pi. Now n is greater than negative 2, less than or equals 2. What are the integers that they are greater than negative 2 and less than or equals 2? Of course, they are negative 1, 0, 1, 2. How many? 4. So there are 4. These are not the vertical asymptotes. The vertical asymptotes are here. If you want to find them, you need to go back and substitute by n. This is very suitable when you want to know just the number, what they are. But if you need to find them, this method also is better if you want to find what they are exactly. Now, Shabab, I'll show you like 3 methods. You can use any one you want. If you prefer the first one, it's okay. I want you to apply it here, Shabab. If x equals to a and x equals to b are the vertical asymptotes of this graph, cotan. The question will be the same if we have cosecant. When we talk about the vertical asymptotes, the vertical asymptotes of cotan are the same for cosecant. So now he wants the vertical asymptotes in this interval. Find them, not the number of them. No, find them exactly. Then sum them up. I will give you a Shabab time to solve this, and I will launch a new polling for you, so you can choose the right answer when you finish solving. أرجوكم يا شباب, please take a pen and paper and start think about finding the vertical asymptotes of this. I advise you to do method number 1 here because I think this interval is symmetric. You can do method 1 or method 2 or 3 or the same. Method 1 and 2 and 3, they are the same. So you can sketch the graph and then you will know what are the vertical asymptotes. Just you need to make sure that you have what you have, they are all the vertical asymptotes between negative pi over 3 and pi over 3. For those who didn't start, how to start? 2 methods. If you want to use method 1, put this between, what is this, cotan? Put it between pi and 0. Continue. Now you will get 2. Are they the only ones in this interval? This will be okay. If you have more inside that interval, you need to make sure about that. This is method number 1. Method number 2, this argument, this is the argument, both it equals to, what is this? This is cotan. Cotan, it is cosine over sine. So both it equals to the zeros of sine. What are the zeros of sine? In pi. لو كانت tan كنا راح نحطها تساوي 2 pi over 2. So both this equals to the zeros of sine which is in y. Solve this for x. وبعدين put it between negative pi over 3 and pi over 3. Solve it for n, you to know what's n. Or try n equals 1, n equals 2, n equals 3, and n equals negative 1, negative 2, and so on. If you use the first method, you need to find the period and you need to add it every time. We don't have much time, Shabab. Please hurry up. So this is about the second method that I told you. You will put it equals to n pi. Then you will solve it for x. So you will add pi over 3 to there, then divide by 3. So these are all the vertical asymptotes. We don't need all of them. We need just the ones that they are here in this interval. So what I will do, I will put my x there. I will put my n there in between. I will solve it for n to know which one are appropriate. Solve this for n, multiply by 3, divide by pi, and here we are. N is between negative, it is negative 2 over 3 and 4 over 3. So this is one way. Another way, Shabab, is to try n equals 1, try n equals 1 to n equals negative 1, and check are they here or not. So now what are the, this is negative 1, this is negative, this is 2, 1, 0. Now negative 2 over 3 is here. 4 over 3 is here. So now what are the integers between these two numbers? 0 and 1. So this means that n is 0 and 1. So we have 2 vertical asymptotes, but these are not the vertical asymptotes. We need to find them. We will go back here. Both n equals to 0, both n equals to 1, you will get them. Here they are. If n is 0, this is what you will have. If n is 1, this is what you have. And you are lucky, by the way, here. Those who use method number 1, they are lucky. But how can they guarantee that there is no other number? So for those who use method number 1, what they did, they put this between pi and 0. Then they solve it. So what you'll have, pi minus pi over 3, it will be 2 pi over 3, greater than negative pi over 3, divide by x, negative pi over 9. So here, these are the first vertical asymptotes. Now, how to guarantee that there is no others? You will go to the x-axis. This is negative pi over 2. This is 2 pi over 9. What you will do, you need to add the period to know the next one, to add the period to the next one. What is the period? The period is pi over 3. So if you add pi over 3, by the way, it is 3 pi over 9. So this will be 5 pi over 9. Now, this one is greater than pi over 3. Pi over 3 is here. And if you subtract now, what you will get, if you subtract the negative, it will be negative 2 pi over 9. And this is, of course, greater than negative pi over 3. But this one, ya shabab, you may miss. This is not guaranteed. You may miss some. But for this one, you will not miss any one. Add them now. It is pi over 9.
Doctor,
Yeah.
the best one to use is method 2, صح?
This one is the best. This is my favorite, but you can use whatever you want. Okay? This is what I recommend you to use. This type of questions, ya shabab, is also important, but I don't have time to do it. So I will leave it for you. When you have the graph, how to find which function has this graph. I give you, for some questions, I give you a hint like this. So for this question, for example, find the period from the graph. What is the period from the graph, shabab? The period is the graph is the length of the interval. For example, for this one, the period is 3. So it is when you have one cup and one cup, so this is one full period. Okay. Now from the graphs, find the period here, which is 2 pi over k. You remember, 2 pi over k equals to what? It must be equal to 3. If it is not, you need to know what is k. This is k, for example, here, k here. And of course, you can exclude some values like that. Then check the vertical asymptotes for those functions. Then you can use, of course, some other y values. Of course, there are other questions and with additional exercises with the full solution. I will leave them for you, Shabab, and we will go to introduce you to 6.5 if there is no questions. Any question, Shabab? Because I will go to introduce you today to 6.5, and then inshallah we will continue this section tomorrow. Okay, let's stop sharing and let me share with you the slides of section 6.5. Okay, as you know, Shabab, 6.5 plus, this is a plus 5.4, by the way. But of course, we already included this section here. This section is the last section in chapter 6, and it is the last section included in the midterm exam. It is about inverse trigonometric functions. We will not focus on the graphs, by the way. Just we will mention them for you to know. So we will not ask you to sketch the graphs of sine and cosine inverses. What they are and from where they come, this is what we are going to see together, inshallah. But before that, you need to remember section 2.8. If you have a one-to-one function, then it has an inverse, and the definition of the inverse will be like this: if inverse of y is x, if f of x is y. The range of the inverse is the domain of the inverse is the range of the function, and vice versa. How to obtain the graph of the inverse is obtained by reflecting the graph of the function at the line y equals x. The inverse function property or the cancellation property, we will use them, ya shabab, here. What is this graph is for? This is the graph of which function? What is this function, ya shabab?
Sine.
It is sine. Is it one-to-one? It is not one-to-one. If you draw any horizontal line, it will intersect it infinitely many times, not only once. So it is not one-to-one. So, بما أنه هي not one-to-one, it has no inverse. Is that right? If for the inverse to be a function,
Have to be one-to-one.
What we should do, we will do the same. You remember secant x squared. It wasn't one-to-one, so it has no inverse. What we did, we restrict the domain. We just take the right part or the left part. Then it becomes one-to-one, and then we had an inverse for this function. We will do the same here, Shabab. We will take a part, we will take an arc from the graph that is one-to-one. And I think if you look at the red one, it is the largest one that we can take, and we have it, of course, one-to-one. You can take this from here to here also, but let's make it easy. Let's take the first one that is close to the zero. So we take this interval from here to here. Now this one, It is not sine, by the way. It is part from the graph of sine. It is arc from the sine. It is sine x between negative pi over 2 and pi over 2. So this is also, it has a name. You can call it restricted sine, not sine. This is restricted sine. Now, this function is one-to-one. If you draw any horizontal line, it will intersect it only once. So it is one-to-one. Because it is one-to-one, what we have, it has an inverse. So how its graph or how its inverse looks like? Its inverse, we know that the graph of the inverse obtained by reflecting the graph, reflect the graph on the line y equals x. If you reflect it, you will get this graph. Now this graph is for sine inverse. So you can see clearly from the graph that the range is from negative pi over 2 to pi over 2. And the domain is from negative 1 to 1. So this is a new function that we call sine inverse, or they call it sometimes arc sine. From where this word arc coming? From this arc, from this part. Arc, it means part from the graph. Now this is the definition of the inverse sine, which is the same, ya shabab, as the inverse function definition. Just right here, instead of sine, f, and this, of course, f inverse, this is f, and it is the same definition. Okay, so sine inverse, it is a function, this is its domain, and this is its range. Okay, by the way, the domain is the same as the range of the restricted sine, and of course, the range is the same as the domain of the restricted sine. We call it like this, or shortly we write it like this. I wish this is clear. Now, what is sine x? When you think about sine inverse x, you are thinking about a number in this interval that its sine is x. Let's take an example about that. But before that, let me mention what is wrong. Now, let me mention the cancellation properties. Sine inverse of x is x. Of course, this is f. If you just put f inverse, if you remember 2.8, the same. But be careful, this x is not the same as this x. This x, it is where? In the domain of sine inverse. So this is the domain of sine inverse. And this x, it is in the domain of the restricted sine. So to forget, you may confuse between sine and the restricted sine. Indeed, this is in the range of the inverse. Okay, so it is better to remember it like that. The second one, you need to pay more attention to the second one because most of the mistakes are here. Let me summarize for you the domain of this function, the range. These are some values, and this is the graph. And of course, you can see that it is increasing, the decreasing x-intercept and the y-intercept are the origin. What is good about this inverse, this sine inverse? It is odd. You can see that it is symmetric about the origin. Sine inverse negative x is negative sine inverse x. Keep this in mind. It will help you. Only sine inverse and tan inverse will be odd. The others will be neither. Now this is the good part that I want you to have an idea about. What is sine inverse a half, shabab? Who can tell me? What is sine inverse a half?
Uh, 30
what?
30 degree.
30 degrees.
Which is pi over 6.
Is it in this interval? No. So this is not an answer. We are talking about an interval, ya shabab. Interval here, real numbers. We want a number between negative pi over 2 and pi over 2. This is not 90 degrees, ya shabab, here, and this is not negative 90 degrees. This is not what we are talking about here. We are not talking about degrees at all. What is 30 degrees in radians?
Pi over 6.
Pi over 6. So the answer is pi over 6. The answer is pi over 6. How to check that your answer is correct? You need to check two things. First of all, is this belongs to this interval? Is it in or out? Is it in this interval? Is pi over 6 is here? This is 0. Is it here? Yes. So this is the first thing. The second thing you need to check is, ask yourself, is sine pi over 6 equals to a half? To make sure that your answer is correct? Yes. So what is the justification of this answer? The number is in this interval and its sign is a half. This is all what we have for today, Shabab. We will stop here and continue tomorrow, inshallah. Thank you and see you tomorrow. If you have any questions, Shabab, please, I will be glad to answer.